The Type 055 Renhai and the Arleigh Burke Flight 3 are frequently compared as rival destroyers, but the comparison is historically lopsided in ways that raw specifications cannot capture. The 055, commissioned from 2020 onward, is a clean-sheet 12,000 to 13,000-ton cruiser-sized warship built with deliberate weight, space, and power reserves that Chinese shipbuilders could allocate without the constraints of a legacy hull. The Flight 3, by contrast, is the latest iteration of a destroyer design conceived in the early 1980s, a 9,700-ton platform that has been stretched across 4 decades to carry combat systems far heavier and power-hungrier than its original architects ever anticipated. What is missing from nearly every popular comparison is the fact that the U.S. Navy itself designed a ship very much like the Type 055 in the late 1980s, the Cruiser Baseline, or CGBL, only to cancel it before any steel was cut. CGBL was an all-steel 13,600-ton guided missile cruiser that packaged the combat capability of a VLS-equipped Ticonderoga into a hull built to Arleigh Burke construction standards, complete with armored superstructure, a flush deck, and a secondary combat information center. It was not a design for directed energy weapons, which lay decades into the future, but a prudent, incremental step focused on securing the weight, space, and electrical margins that a long service life would inevitably demand, exactly the kind of practical technology bridge that the Type 055 now represents for the People's Liberation Army Navy.
In engineering terms, a practical technology is an intermediate system that reduces risk by providing real operational experience before committing to more ambitious designs. CGBL was precisely such a stepping stone. It would have let the Navy learn how to operate a large steel cruiser with the physical margins to accept larger radar arrays, deeper missile cells, and the additional command spaces that a Strike Group Air Defense Commander requires, all while using mature LM2500 gas turbines and Aegis combat system variants already in the fleet. Had even a modest class of CGBLs been built in the 1990s or early 2000s, the institutional knowledge of designing, constructing, and sustaining a modern cruiser would have been continuously refreshed. Instead, the end of the Cold War and the resulting budget drawdown killed CGBL before it reached a shipyard, and the Navy chose to press the Ticonderogas far beyond their intended service lives while squeezing ever more capability out of the smaller Arleigh Burke hull. The Type 055 is, in effect, a physical realization of the CGBL concept that the United States walked away from, a 180-meter, 13,000-ton cruiser built from the keel up with margins for growth, commissioned by a rival navy that was still operating obsolete destroyers when the CGBL study was filed. The comparison between the 055 and the Flight 3 is therefore not a contest between two contemporary designs, but between a cruiser that was built with foresight and a destroyer that has been compelled to fill the role of the cruiser the United States chose not to build.
Physical size is the irreducible foundation of growth margin, and on this point, the Type 055 and the Arleigh Burke Flight 3 diverge decisively. The 055 stretches 180 meters in length with a beam of 20 meters and a full load displacement generally estimated between 12,000 and 13,000 metric tons, while the Flight 3, at 155 meters long and with a full load displacement of roughly 9,700 to 9,900 tons, is some 2,500 to 3,300 tons lighter. That extra displacement translates directly into reserve buoyancy, larger machinery rooms, deeper vertical launch cells, and accommodations that can absorb new systems without forcing painful trade-offs elsewhere. The Flight 3, by contrast, is a hull that has been loaded with a larger radar, upgraded generators, and enhanced cooling systems while remaining within a physical envelope that was never meant to accommodate them all simultaneously. Naval Sea Systems Command has succeeded in giving the Flight 3 genuine headroom in electrical power and cooling. The ship is not a zero-sum compromise, but that headroom exists within a constrained volume, not the expansive margins of a cruiser-sized hull. The Type 055, simply by being larger, possesses a physical growth capacity that the Flight 3 cannot match, regardless of how ingeniously its power architecture is redesigned, a reality the U.S. Navy implicitly acknowledged when it concluded that a destroyer hull could no longer contain the future requirements of the Air Defense Commander mission. Power generation figures have become a favored metric in Type 055 versus Burke comparisons, but the numbers must be interpreted with an understanding of shipboard electrical architecture. Open-source estimates credit the 055 with 6 QD50 gas turbines rated at approximately 5 megawatts each, yielding a total installed generating capacity of roughly 30 megawatts, while the Flight 3 carries 3 AG9610 generators, producing approximately 12 megawatts. These raw figures, however, do not tell the whole story. The 055 does not yet possess integrated electric propulsion, meaning its propulsion power and electrical power remain largely segregated, and Chinese sources acknowledge that fielding railguns or high-power lasers will require a transition to IEP first, a step that may come with later batches but has not been confirmed on the current units. The Flight 3's upgraded generators were specifically integrated to supply the SPY-6 radar and leave a margin for future loads, and the U.S. Navy has already fielded the Helios 60-kilowatt laser on an Arleigh Burke hull. Both ships, therefore, face real architectural constraints that limit how much of their installed megawatts can actually reach an energy weapon today. Where the 055 holds a meaningful advantage is in the future. Its larger hull can physically accommodate the generators, power conversion modules, and thermal management equipment that an IEP retrofit would demand, while the Burke has no comparable volume to accept such a transformation. The 055's electrical potential is greater over the long term, but it remains a promise rather than a deployed capability. The sensor suites aboard the two ships reflect their divergent design priorities. The Burke Flight 3's AN/SPY-6V1 is an S-band gallium nitride radar of extraordinary sensitivity, widely assessed as offering approximately 30 times the performance of the legacy SPY-1D, while the Type 055 fields a dual-band combination of the S-band Type 346B and a dedicated X-band radar for precision tracking and horizon illumination. Independent estimates place the SPY-6's detection range against typical air targets well beyond the Type 346B's, giving the American destroyer a meaningful advantage in long-range volume search and ballistic missile defense discrimination. The Chinese dual-band suite, however, presents an electronic warfare dilemma. An adversary attempting to jam the S-band array must still contend with the X-band system, and this multi-frequency redundancy makes the 055 harder to blind in a contested electromagnetic environment, even if its individual radar panels may be less sensitive than the SPY-6. The CGBL design, it is worth noting, was conceived before dual-band radars were operational, but its generous superstructure volume and power reserves would have accommodated such a system without the painful space compromises that the Burke Flight 3 had to accept when integrating the SPY-6 array. No single feature defines the tactical asymmetry between the Type 055 and the Arleigh Burke Flight 3 more starkly than the vertical launch system. The 055 carries 112 cells of the universal UVLS, each with a diameter of 850 millimeters and a depth of approximately 9 meters, while the Burke's 96 Mk41 cells are constrained to a 635 millimeter diameter and a strike length depth of 7.6 meters. The larger Chinese cell physically accommodates the YJ-21 anti-ship ballistic missile, a weapon assessed by open-source analysts to reach hypersonic speeds and a range on the order of 1,000 to 1,500 kilometers, putting a carrier strike group at risk from well beyond the effective anti-surface envelope of the SM-6. The Mk-41, for all its proven versatility and its deep ecosystem of quad-packed ESSMs, SM-3 ballistic missile defense interceptors, and multi-mission Tomahawks, cannot accept a large-diameter hypersonic anti-ship missile without a hull redesign around a larger launcher. CGBL, with its cruiser-sized hull and generous deck space, was designed to avoid exactly this trap, providing the physical volume to field larger cells and deeper magazines as missile dimensions grew over the decades. The U.S. Navy is now pursuing the conventional prompt strike system on the Zumwalt-class and planning large cells for the DDG-X and BBG-X, but those programs are responses to a limitation that the cancellation of CGBL locked into the fleet 35 years ago. In the hypersonic Salvo race, the Type 055 has a built-in advantage that the Flight 3 cannot close through software or sensor upgrades alone. For much of its history, the People's Liberation Army Navy was regarded as a laggard in anti-submarine warfare, but the Type 055 sensor suite indicates a serious effort to close that gap. The ship is equipped with a large bow sonar, a towed array sonar system, and, according to multiple open-source analyses, is fitted with a stern port consistent with a variable depth sonar installation, though whether an operational VDS is routinely embarked remains unconfirmed. The Arleigh Burke Flight 3 carries the SQS-53C hull sonar and the TB-37U multifunction towed array, a mature and combat-proven combination that is primarily passive but supplemented by the active dipping sonar of the embarked MH-60R helicopter, which serves as the ship's organic active depth search capability. The Chinese U-8 rocket-delivered torpedo offers a standoff engagement range estimated at approximately 40 kilometers, significantly exceeding the roughly 22-kilometer reach of the American RUM-139C VLA, giving the 055 the ability to strike a submarine contact from a safer distance. The U.S. Navy retains a qualitative edge in acoustic processing, crew training, and the integration of the MH-60R platform, but the raw sensor and weapon performance data suggest that the 055 is no longer outclassed underwater. The growth margin inherent in the 055's hull means that future ASW upgrades, more powerful sonar transmitters, larger towed bodies, onboard unmanned aerial vehicle hangars can be accommodated without the volume constraints that would prevent an equivalent retrofit on a Burke. The Arleigh Burke Flight 3's greatest asymmetric advantage is not in its hull or its magazine, but in the combat system and the networking protocols that surround it. Aegis Baseline 10, the cooperative engagement capability, and the Naval Integrated Fire Control Counter-Air Architecture allow a Flight 3 destroyer to receive targeting data from an F-35C, an E-2D Advanced Hawkeye, or another Aegis ship and launch SM-6 missiles against over-the-horizon threats without ever radiating its own radar. This distributed kill web multiplies the effectiveness of every sensor in the battle group and creates a targeting problem that is vastly more complex than the radar range of any single ship. The Type 055, while equipped with a modern integrated combat system that has demonstrated multi-target engagement in exercises, has not yet been observed conducting the kind of seamless, cross-platform, sensor-to-shooter engagements that the U.S. Navy and its allies have been refining for over 2 decades. Moreover, the Flight 3 operates within a coalition ecosystem that includes Japanese Maya-class, Korean Sejong the Great-class, and Australian Hobart-class Aegis ships, all interoperable and sharing a common tactical picture, while the People's Liberation Army Navy has no comparable network of allied high-end combatants. The 055's physical margin is formidable, but the Flight 3's networked margin is the product of an accumulated operational and diplomatic investment that cannot be replicated by a larger hull.
Survivability is the most difficult quality to compare because the Type 055 has never been subjected to combat damage, while the Arleigh Burke class has decades of real-world damage control experience informing its design and training. The Flight 3 is built to the MIL S901D shock hardening standard, with Kevlar armor over vital spaces, extensive redundancy, and a damage control doctrine that has been tested in collisions, fires, and hostile actions. The Type 055's larger size grants it substantially greater reserve buoyancy, meaning it can flood more compartments before losing stability, and its steel construction and compartmentalization reflect modern Chinese naval standards that are considerably more robust than those of earlier generations. What remains unknown is how well the Chinese crew training, automated firefighting systems, and damage control organization would perform under the extreme stress of a missile impact. The CGBL design notably included a secondary combat information center with independent Tomahawk launch capability, a feature born of the recognition that a cruiser acting as air defense commander would be a primary target and had to keep fighting even after a hit. Whether the Type 055 incorporates equivalent redundant command spaces is not publicly confirmed, though its larger hull certainly offers the volume for such a feature if the Chinese Navy chose to prioritize it. In a sustained fleet engagement, the American ship's battle-proven resilience and networked command redundancy might offset the physical vulnerability of its older hull, but the Chinese ship's sheer size gives it an inherent capacity to absorb punishment that the destroyer simply cannot match.
Assessing which warship would prove superior in a 2030s great power conflict requires abandoning the one-on-one duel in favor of examining how each platform fits into its Navy's operational doctrine. The Type 055, with its hypersonic reach, large magazine, and deep growth margins, is tailor-made as an offensive spear that can threaten a carrier strike group from outside the effective defensive perimeter of its escorts, a modern realization of the heavy cruiser concept that the United States abandoned with the cancellation of CGBL. The Arleigh Burke Flight 3, by contrast, is the ultimate defensive shield, optimized for ballistic missile defense, anti-air warfare, and integration into an allied network that spans the Pacific, and it will be fighting alongside the first DDG-X hulls and eventually the BBG-X battleships we discussed in a previous video. Platforms that themselves represent the belated American acknowledgement that the cruiser-sized hull was necessary all along. If a Type 055 can deliver an undetected YJ-21 salvo, it could shift the balance of a campaign in minutes. But if a Flight 3 leverages off-board sensors and coalition data links to strike first with a coordinated volley of SM-6 and Tomahawk missiles, it can neutralize the threat before the 055 enters its own firing envelope. The American ship benefits from an unmatched ecosystem of allies and 40 years of continuous combat system iteration, while the Chinese cruiser enjoys the momentum of rapid production, lower unit cost, and a hull that can accept technologies not yet invented. Neither platform is categorically superior, but the historical irony is unmistakable. The Type 055 is, in its essentials, the ship the U.S. Navy designed in 1988 and chose not to build, and the American fleet will now spend the 2030s scrambling to field its successor. The winner will be the force that best integrates its platforms, sensors, and decision-making into a cohesive whole, and the margin for error in that integration is precisely what CGBL was supposed to provide.